Hello, welcome to a new Design Automations podcast series, Thought Leaders on the Future of System Design and EDA. Our primary focus is to discuss system design challenges, especially those related to long lifecycle markets. My name is Krishna Banka, your host for this podcast. I have over 2 decades of professional experience in semiconductors and EDA, having worked with companies like Synopsys, Cadence, and Keysight. My guest today is Dr. Rahul Razdan, founder of a new and industry veteran in semiconductors, ED, and AI. Welcome to the podcast, Rahul. Why don't you introduce yourself to our audience? Tell us about your professional journey.
Sure. Thanks, Krishna. Well, my professional journey started out at Digital Equipment, where I was a CPU designer for a long time, Alpha microprocessors. Then I went over to Cadence, and I ran a big chunk of Cadence, the verification business and systems business. Then I went over to a company called Flextronics. They're at EMS, and that's actually where I started seeing the initial problems we'll discuss today. And then since then, I've been doing a lot of startups. I've done a startup in wireless power. I've done startups in EDA, and I'm doing this startup within you, which I hope will be very impactful.
Sure. So let me start with your thoughts on the evolution of electronics design. Being an industry veteran, how have you seen things changing over a period of time?
Well, when I started my career at DEC, which was 40 years ago, the system designer, I'll call it the PCB designer, was assembling obviously semiconductors, but the semiconductors were relatively simple in those days. The most complex things were bit slice processors and things like that. And so when we were doing system design, we were just trying to get some interesting function built. That was the main task of the system designer. And this, of course, the electronic systems could not be very complex because the amount of functionality that you could build was relatively small. Well, today, of course, everything has changed. You know, the semiconductors, after 40 years of Moore's Law, have had an enormous amount of capability. And what's interesting is that over that period of time, in order to do that, the EDA function has had to adopt. Obviously, the processing function semiconductor process function has to adapt, and so on. Meanwhile, on the system design side, interestingly, the job has really changed. It's changed from designing function to figuring out how to manage these really complex designs and semiconductors. Meanwhile, the kind of the physical part of it is not that different than it was 40 years ago. And that's why we find the EDA functionality is about the same, with some exceptions.
So what exactly motivated you to start a new design automation?
Well, when I was at Flextronics, I kept running into customer after customer that had the following problem. They were in the so-called long life cycle segment, so they were in defense or health or agriculture, or anything except consumer. And the problems they had was, number one, they were not typically electronics savvy or deep. They were trying to use electronics to solve their system problem, right? And so therefore, they didn't have large teams like consumer companies have. The second thing was they were trying to use semiconductors, but it's extremely complex for them to actually even understand what's available and sort of all the things that are involved with that. And of course, these days, it's not just hardware, it's also software, it's operating systems, it's support packages, it's AI now, AI systems. And then once they built the system, what I noticed was they would run into a lot of issues with obsolescence or reliability, or how do I design the system in such a way that if I'm embedding it in the field, that I have an easy way of updating it. All of these things are what I'd call electronic system design related capabilities, which they were all having very much difficulty with, which, as an aside, the EDA industry didn't provide any capability. So I saw an opportunity there.
Right. So I definitely think what you just mentioned brings us to a valid point that there has been a host of challenges which are differentiated in terms of system design versus PCB design versus semiconductor design. And when we take them towards the long life cycle versus short life cycle criterion, I think they start manifesting themselves differently. So what is your take on these aspects of system design and electronics design automation?
Well, I mean, historically, what's happened is that on the PCB or system design, it's been mostly a physical design process. The platform we have, Allegro or the platforms from Mentor Graphics or other such companies, you'd be surprised. They're literally 30 years old, 40 years old. They're actually the same platforms. Now they've added functionality. They've added advanced packaging, signal integrity, things like that. But interestingly, they have not veered up from the physical design realm into the logical design realm, or certainly the AI realm, right? So on the EDA side, there's been this gap created, and you might ask the question, well, if it's such a problem, why haven't they addressed this problem? And the interesting thing is, for most of the EDA companies that own these platforms are actually part of obviously larger EDA companies, Cadence being an example. And the vast majority of the income that a company like Cadence makes is actually in the semiconductor side. So when they look over at the system design market, they see a market that tends to have much lower ASPs. And if you were doing the comparison, the Moore's law is driving a retooling cycle on the semiconductor side, and therefore we can get it. You're incentivized to invest in that area. In this other area, you don't have those dynamics, and a lot of the companies that we're talking about in this long life cycle segment, the fundamental business model is also different. Many of these companies, they don't make money on the initial product sale or the initial service sale. Typically, they actually make it on maintenance. And so EDA doesn't even have a good business model for tapping into that maintenance revenue.
Right. So when you talk about the long life cycle markets, what are its unique propositions with respect to the SLCs, the smaller life cycle markets? What is that it makes this particular industry unique in terms of electronics automation?
You have to kind of understand a very basic fact, which is in terms of semiconductor volume. So this is from a semiconductor company's point of view, and if you're looking out, the vast majority of the volume, in the order of 90%, is consumed by the consumer industry. So your iPhone, your laptop, things like that, they consume the vast amount of semiconductor volume. And so what that means is that if you're a semiconductor company and you're sort of feeding the LLC market, that's perhaps that's 10 or 15% of the overall market. And on top of that, it's a very fragmented market. It's actually a collection of micro markets. And so since that's the headset, you don't really design for this market. So if you're going to build reliability parts with the reliability, you're going to aim for the consumer market. And so therefore the extended reliability requirements of the long life cycle products won't be handled at the semiconductor level. They have to be handled at the system level, right? And so the contrast is the way you look at it is, if I'm an LLC designer, I'm facing a situation in the marketplace where the most critical resource I have, the semiconductors, are actually churning very fast, and they're being built for another market. And I have to still sample, I still have to consume these important chips, but then I still have to figure out how to actually use them in my application, despite the fact that they're not built for my application.
And how do unused software solutions help address those kinds of challenges, specifically when we talk about being able to manage the total life cycle cost for these LLC markets? So how do your solutions help tap into these challenges?
Well, in three ways. So the first thing is, in order to just understand how to design, you have to sort of reduce the complexity of these semiconductor systems in a way that the productivity of design is better. One of the reasons this is an issue is, if you look in these LLC markets and you ask the question, why does somebody use a particular IC?
Right.
They actually use it because they used it before. And so therefore this familiarity is what drives everything, which of course has a huge opportunity cost because they're not looking at other ICs that could be even more helpful to them. So, and the reason is very simple. They don't want to go through the complexity of having to understand a new IC system, right? So if you can reduce that complexity, then more capabilities available. So that's the first thing we do. The second thing is the unique issues of long lifecycle products, such as reliability or obsolescence or future function changes. They can all be handled with the system design paradigms. And so as an example, the more programmability you have, the better you have, the more robustness you have against many of these issues. So Anu has a design for supply chain capability that addresses many of these sorts of issues. That's how we handle this. We've actually moved this in the realm of design, which is why an EDA functionality is very much required.
And how does a new solutions that you just mentioned, how do they help lifecycle management for an effective enterprise PLM system? And how do they enable the ecosystem partners?
So we typically have 3 or 4, I'll call it important ecosystem partners. Obviously, the traditional PCB companies like Cadence and Mentor Graphics and others that have the physical design tools, they are as it were, at the bottom of our design chain. So the output of our tools produces chips that then go into a typical physical design process. So that's one partner. Another partner we have are the PLM companies. Now, the value of PLM is it's the centralized repository of knowledge across an enterprise. So it can connect R&D with manufacturing with maintenance and so on, and finance and so on. So the issue in electronics that always has been, since the domain-specific design system for system design doesn't exist, the knowledge that's required and consumed across the enterprise for that function does not exist. So we connect to the PLM system with that knowledge. Let me give you an example. Let's say your field organization is finding huge reliability issues with some of your semiconductor parts. Well, with our system, that organization can discover what the issue is, point out the parts or the parts locus which are causing the problem, put them in the PLM system in such a way that the system designer for the next product has access to that information. Maybe this is another thing I should mention. Reliability is a very big issue in a lot of these long life cycle systems, but reliability for semiconductors is actually not a very well understood thing. And it's very different based on the end market. So if you're in a data center, you'll have a certain reliability profile. But if you're in the field, or if you're in an automobile, you'll have different reliability profiles. And really, the only people that understand this well and that have the data for it are the system design teams and their maintenance organizations. So with our system, we can build these sorts of linkages that don't really exist today.
Yeah, and definitely those kinds of relationships and linkages will help the entire ecosystem. It'll allow interworking of OEMs with the design services, let's say the EMS and the distributors. It'll also enable collaboration between procurement and system design teams. At the same time, the semiconductor and EDA companies can also chip in and participate in this entire ecosystem to make system design healthier as a process.
Absolutely.
Well, great conversation, Rahul. Thank you again for your time, and I hope we will have you back in future for another such podcast. That concludes our podcast. Any topics you would like us to cover, please leave a comment. Thank you everyone for your attention. Have a great day.